Yeah.
Hello, can you hear us?
Some issues with your microphone. Just minor.
All right, can you hear us?
Make sure you guys don't have two mics open at your university at a time.
Yeah, that's what. All right. Can you hear us now?
Yes, we can hear only one of you now, so that's good.
All right, perfect. Okay, so. Can everybody see this?
Yes.
Yes.
All right, perfect. We'll go and get started.
All right, well, good morning, everyone. My name is Matt Fulford from Team 5, also known as Team Galadrius, and our mission concept review this morning will center on a search and rescue UAV for the Appalachian Trail. Here's a brief breakdown of what we'll be talking about this morning. I will start with an overview of our concept and then hand it off to some others for the breakdown of the mission. So the initial concept for this mission came from an event that has impacted the Midwest area in recent months. Some of you may have heard of a young woman named Molly Tibbetts. She was a University of Iowa student that was kidnapped while out for a run, making national headlines as people spread awareness and searched for her. After months and months of searching, eventually her body was found in a cornfield just less than an hour away from where she had initially disappeared. This tragic event really impacted a lot of people here at Iowa State, especially me, and it really made me wonder if there was a way we could use aerospace engineering to make a difference. I thought, what if instead of people walking and relying on eyesight for location, we could use advancements in aerial surveillance to locate a missing person? From this, the initial concept for an emergency search and rescue UAV was brought to the table. After discussing the potentials for this mission, we realized that most people will have a cell phone on them at all times, but may not always be able to physically use them, or especially if they're out in an area that has no cell service. For example, a national park that has a lot of different elevations and very dense tree coverage. However, the cell phone is still going to be broadcasting a signal while it looks for service. And with the right technology, this signal can be detected and the location can be determined once you get close enough. If we were to implement one of these such devices in a UAV, it would be able to quickly fly over the trees looking for a cell signal. As you can see from these statistics here, there are thousands and thousands of injuries and fatalities in national parks each year, creating a very high demand for improvements to the speed and precision of rescue missions in these locations. Many different people would benefit from having a technology like this readily available. Any emergency rescue personnel, for example, the National Park Service, Coast Guard, even police, would be able to use this UAV and assist them in the search. Along with that, it would also reassure people who may be hiking in no cell coverage areas that there is still a way that they can be located in case of emergency. Specifically, we reached out to a park ranger at Yellowstone National Park about the idea, and he initially told us that people are often found very close to the trail, going on to say that having a UAV such as this one that could fly quickly along either side of the trail would be very beneficial for them to invest in. So for our specific UAV, the conditions are going to mimic the Appalachian Trail, as this is a very popular yet sometimes dangerous tourist attraction here in the U.S. UAV will be programmed to fly along a set path of GPS waypoints using an internal device to search for a signal coming from a missing or lost person's cell phone. Once this cell phone is detected, the UAV can then broadcast this location back to responders while also loitering overhead of the person, providing a distinct aerial location to make it even easier for first respondents or even other nearby hikers to identify this missing person's location. Now, one thing that we considered is that this whole idea centers around the premise that somebody will have their cell phone on them. Some of you may be wondering, why would a person still have their phone on them even if it doesn't have service? While this may have been true decades ago, we considered that people will still have their cell phone on them because it is used for so much more. People take videos, they will listen to music, they can read a book on there. And so we considered this, and we decided that the chances that people won't have a cell phone will be very, very low. I will now let our project manager, Khalid, take over and continue explaining our mission.
Hello, I'm Hassan, project manager.
Do you have your mic on?
So when we why is it? Sorry. Sorry about that. When we were trying to come up with the concept for our UAV, we created a standard document for each team member to input to propose their mission. This includes design features, applicable markets, as well as their personal list of pros and cons. We turned this into a form so everybody can have the chance to input their thoughts about each concept using pros and cons. After we finished all documentations, we held a meeting to discuss different concepts amongst ourselves and tweak some of the ideas. Later, we had a vote, and we chose to go with the search and rescue UAV. So this UAV, as Matt mentioned already, will operate in the Appalachian Trail. Once there is a report of a missing person, the UAV will be launched from a home base and will follow a pre-programmed path to sweep as much area as possible using some algorithm. This UAV will be equipped with an RF sniffer with certain coverage range, which will essentially try to locate a cell phone signal. Once the signal is located, the UAV will come closer to it and will send an accurate GPS coordinates to ground control to deploy aid. The UAV will then initiate a return to home protocol. We came up with a list of top level requirements based on our mission. As you can see, the UAV will be hand launched. That's based on Boeing's requirements, and it shall fly autonomously in a pre-programmed path so that we can have some freedom of travel. It shall be able to locate cell phone signals in places with no cell phone coverage. It shall be able to transmit GPS coordinates of the found person to ground control. It also shall be portable for ease of transport, and it shall be able to survey the trail in a pre-programmed path for efficiency. As for the performance requirements, we decided the system shall not weigh over 11 pounds for ease of launch. It shall stay in the air for at least 1 hour and a maximum of 4 hours to survey as much land as possible, since the RF can operate for 4 hours, maximum 4 hours in one full charge. It shall have a maximum speed of 30 miles per hour to increase endurance. And finally, it shall have a range of 20 miles to be able to survey 7 square miles of land based on a low ball 1,000 feet RF detecting diameter. To accomplish all of our goals, we had to divide our roles amongst ourselves, amongst the team members for the form of department leads. As you can see, every and each one of us has a leadership position of some sort, and will all directly communicate amongst ourselves using this form of breakdown. Of course, these are just lead positions, and everyone will be involved in other teams, helping out as much as needed, so that we all have an idea of what's going on if something comes up. Next, I will have Kyle, the chief engineer, dive deeper into some of the specifics of this mission.
All right, good morning, everybody. Like Kyle had said, my name is Kyle Jeanette, and I'm chief engineer for Team Caladrius. Work breakdown structure is organized on the disciplines which were determined to be necessary to complete this UAV. Here's a high-level perspective of the end items each group will be accountable for and is expected to complete in a timely manner. Like Kyle had said, though we are divided into teams and disciplines, our team of 9 members is small enough that it will be necessary for the group to interact and overlap as in each aspect. However, there is a lead assigned to be the accountable person for each team. In the design phase of this project, the work breakdown structure will continue to be added to such that the task can be tracked in the Gantt chart and each high-level objective can be completed. Each color here represents a different phase in the project or internal team goals. The pink bar in the middle represents our team's internal testing goals for this project. These are preliminary times, but as it is now, the schedule provides buffer days in case of unexpected or unforeseen events. This is simply an overall view of the project timeline as the discipline-specific plans are being developed. Like the previous chart, this shows an overall schedule of the fall semester deadlines and presentation or report due dates. This is again a high-level view which is currently being bulked up in the individual discipline context. Here is our initial cost estimate we put together for how we plan to allocate our funds. The avionics accounts for our sensors, onboard computers, and trackers, which are specialized items needed to complete our mission. The propulsion and actuation category accounts for the basic components to make our aircraft fly: motors, ESCs, servos, etc. As you can see, we have also allocated funds for building material as well as shipping costs and any unfortunate or unforeseen repairs we may have. With this budget estimate, we have an approximate buffer zone of about $1,600. For our payload, we included all additional avionics we will need to complete our mission. Since having an actual cell phone tracker is too expensive, they're around $1,500, we are replacing it with a dummy version weighing 2 pounds, having the associated dimensions. Other components include a Raspberry Pi, proximity sensor, GPS sensor, and satellite data link sensor for a total payload of just over 5 pounds. We have also included our power requirements. So based off our flight time requirement of 1 hour or more, we can better estimate what we will need for a power source. The key thing we considered when choosing our payload was how all the different electronics were going to interact with each other within the UAV. For the cell phone detector, we needed to ensure that we had a clear view of the ground and whatever frequency of signal it was attempting to detect would not come from any other electronic components within the UAV disrupting its performance. We also need the proximity sensor to be in clear view at the front of the UAV so it performs at optimal conditions as well. The GPS information needed to communicate back to the home station, which is where the data link component will be used. Tying this all together, we needed an onboard computer, the Raspberry Pi, and then a power source chosen from our payload requirements. Our team saw a need for autonomous search and rescue vehicles, not only in the remote areas of Appalachia, but also in places which hit a little closer to home. With this idea, we'll be able to market it towards different types of search and rescue organizations who may not necessarily have the manpower to continually search vast areas and get to some of the remote locations in the Appalachian area. Before we move to Q&A, I'd like to thank the Boeing Advisory Board and the NASA viewers for signing on this presentation for their expertise and help. With that, I'll open up the presentation for any questions anyone may have. Thank you.
Hi, this is Colin Nelson from Boeing, and I have a question on slide 11 on your requirements. So I noticed that we have pretty specific requirements of like 11 pounds, 1 hour, 30 miles an hour, and 20 miles range. And I was wondering how these numbers, what the rationale for these numbers were, like how did we decide on these specific numbers?
Okay, Kyle from Team 5 here. these numbers were initially brought to us based off of how much the Raspberry Pi and how much the not only the weights of our payload, but also how quickly we wanted to search our area along the Appalachian Trail. So 3 miles an hour is to sweep out an area quickly. Doing the math, at 30 miles an hour for about an hour, and then we're sweeping about 1,000 feet on each side. It's just kind of a internal goal we had of to how much area we wanted to cover and how much time, to kind of an efficiency for those requirements.
Kyle, Hung again. So quick question. So you saying the range is 20 miles, so that's definitely beyond visual line of sight. But I didn't see any discussions or survey on the BV loss, operation, flight safety. So maybe you guys can take a look at that, after this presentation.
Did you say BV loss, Peng?
Beyond visual line of sight, BV loss. You are already flying 20 miles in your range, so it's beyond line of sight of operator. So that's a big issue from FAA. So you need to, anyway, we'll talk about that later.
Yep, okay, thank you.
Cal here from Team 5. If I may add, we actually considered obstacle avoidance system so that it can avoid all of trees and obstacles. Also, for these numbers, these are preliminary numbers that are subject to change. For instance, we came up with like a 1 hour endurance time and a maximum of 4 hours. That's just based on what we found about the detector having 4 hours of operating capability in one charge. So, and 30 miles per hour, we set the maximum so that the RF can have enough time to locate cell phone signals without having any disturbances. Like if it goes too fast, it might not pick up the signal. So these are the things we consider in terms of for like these numbers.
This is Colin again. Yeah, that's good. I do like the simplicity of the requirements. So I think this is a very good start. Just make sure that the requirements are based on what you want to accomplish rather than constraints. So like for example, the no heavier than 11 pounds. So I would think that would come into safety, because if you hit somebody, then you wouldn't want it to hurt them usually. So we put a weight constraint on things like that. But then also you'd have a requirement of payload, because you actually want it to carry the 5-pound sensor that you have. So that's your requirement, to carry the sensor, because we don't care if this thing is 10,000 pounds if it meets all the requirements. Obviously that's going to be constrained by other things, but just putting a blind weight requirement on it wouldn't be sufficient.
Thank you.
Hi, this is Shannon Hunt. Could you guys talk about the hand launch system, or the functional requirement that says the hand launched?
I'm sorry, what about it?
So your requirements say hand launch takeoff. Could you talk a little bit about that?
So this was already set by the Boeing program that this UAV has to be hand launched. This is not up to us. It's already set.
Okay, thanks.
Yeah, this Charlie Kamada, NASA. I think I heard, but I'm not sure if it's correct, that the cell phone tracker was too expensive. Is that correct?
Yeah, Kyle here. Yeah, the cell phone tracker, the price on it was about $1,500 to $2,000. So with that eating up almost a third of our budget, and we decided instead of to do an actual cell phone tracker, we would more or less do a simulation or a proof of concept with that, to where we'd have a GPS signal somewhere or a GPS point somewhere in the field, and then with our scanning of our UAV, it would still scan an area, but as soon as the detecting range, it becomes within range of that GPS coordinate, that is going to be like our simulation of the cell phone signal.
So let me get this straight. Your team totally gave up when you heard the price. Do you have any business majors on your team that maybe said, hey, is there a way we could possibly raise funding to get the sensor?
At this time, we didn't. We can look deeper into that and get back to you if you'd like us.
Yeah, I think we need some entrepreneurs on your team. You know what I mean? I've had high school students go on GoFundMe sites and get funding for instruments. I think you guys could do it.
Okay. Yeah, we'll definitely look into that.
Hi, this is Stephanie on at Boeing. I had a quick question. When you've marketed this to your stakeholders, are you guys planning on selling several of these drones in order to cover the Appalachian Trail entirely and a certain time restriction when you're trying to find somebody, or what's your plan for that?
So Matt here from Team 5. As far as the UAV, once we look at the range of what they're in, there are multiple stations along the trail to where rangers, each one would have a drone to kind of handle their own specific area. And so if somebody was lost along a very long stretch of trail, these drones could be used together to handle each specific area where they're based from.
Okay, sounds good.
I think we still have a couple more minutes here. Anybody else have any other questions?
This is Ravi from Boeing. Just a comment to the any team. These are sort of a prototypes, and it's okay to buy some second-hand sensors or anything that you can buy cheap from eBay. I don't think you really need to go after a brand new product.
Okay.
That's great. Good questions. Again, Team 5, are there any more questions for Team 5? Okay, no. So moving on, we're about 4 minutes ahead of schedule. Team 1 is up next.